Okay, we were discussing about the IP addresses. So last time we discussed use of IP address. If you want to uniquely identify a computer in the network, um, we use IP addresses because what computer understand is numbers, the number formats. So when we look at IP addresses, there are two formats. Version 4, usually we have 32 bits, which use 4 numbers separated by dots. And version 6, it uses 128 bits. Okay, and then we were discussing different the classes. Now, when it comes to use of what we call different networks, when you are creating different networks, we could talk about 5 subclasses. Now, this is old version. We are going to talk about the newer version later on, but first, let's start with the use of 5 subclasses. These are known as class A, class B, class C, class D, and class C. Point is that for each class, we have a different ranges, and you should remember that. Now, when you talk about IP addresses, usually we can find two parts. The two parts are, we normally separate the classes as network part and the host part. Network means we are allocating some of the bits for the network. And the remaining is a host. That means the number of computers we are going to have within the class. So remember we talk about we using 32 bits. That means we are using 4 bytes. So in class A, it uses 1 byte for the network and the remaining for the host. That's how you are going to remember. Class B, you are going to use 2 bytes. Class C, you are going to use 3 bytes. Class D and E usually reserved. D is for the multicast and E for the usually we call reserved. So the actively using classes are class A, class B, and class C. Right. Now we discuss how class A works. In class A, we discuss it uses 1 byte for the network and the remaining for the host byte. And another thing that you need to remember is the first byte is 0. So you will have network ID starts with 0. The remaining bytes, so remaining bits could be used to identify the network, and then the remaining for the host ID. Right. Now, when we talk about the class A, one thing you need to remember is it can contain large number of hosts because we are allocating 24 bits for this. So the network ID is 8 bits and the host we have 24 bits. That is the first thing that you need to remember. Right? Okay. Then when we talk about the class A networks or any network, we talk something called subnet mask. The term, the subnet mask is used to identify number of bits allocated for the network and number of bits allocated for the host. So in a subnet mask, we usually represent network bits with ones and the host bits with 0. Simply as that. And then if you take the default subnet mask for class A, Why we call default? Because later on we are going to change. We can create a network within network. So because of that, this could be changed. But the default means starting. So the starting point, now we know we are allocating 8 bits for the network and the remaining 4 bits for the host. So when we say first network bits, we have 8 bits, and 8 bits are represented with ones and others are 0. So when you convert in decimal, so 8 bits, 1, 8 we have, it's 255. Then the next 8 is 0, next 8 is 0, next 8 is 0. So which means we can say the default subnet mask for class A is 255.0.0.0. Right. The next one is the range of IP addresses. Now, when you talk about the range of IP addresses, we already told that you start with 0, right? When you say 0, then the remaining, the minimum value could be all zeros, but usually the starting value we are not going to talk about. I will talk about the ranges later. So the minimum value that you can have is 1. So the range will start with 1. Then you will have 0 and then all ones. Normally all ones also you are not going to consider. So you will use 126. So the range will be from 1000 to 126,000. Right. The last thing that we are going to discuss is how many computers that you can have. Now, when you say how many computers, we know we are allocating 24 bits. If you have 1 bit, we know you can have 2 computers, 2 bits, 4 computers. Likewise, you are allocating 24 bits. So to identify how many hosts or the computers that you can have, it could be to the power 24. And I told you we are not going to use the first one and the last one. So you remove the last 2. So you end up 16 million computers. So let's talk about the class B networks. In class B, we know that the first 16 bits are allocated for the network and the remaining 16 bits are allocated for the host. That is the first thing that we need to discuss, right? And apart from that, we can discuss, right, how this is started, right? Now in class B, it starts with 1 and 0. So that you need to remember when we talk about this, right? So let's start. Let's take down when we have class B, we can say we are using 16 bits each for the 2 parts. Right? So 16 bits for the network ID and 16 bits for the host ID. That's the first thing. And then when you talk about the network part, so network part start with 1 and 0. So that means the remaining, 14 bits could be anything. So one thing you need to remember, it start with 1, 0. Right. Now, the remaining 16 bits, we will use for host ID, meaning like for the host we are going to allocate. Right. So this is the first thing that we need to discuss. Now, once we talk about this, we can say now the largest networks we could create with class A. Why? We have used 24 bits for the hosts. right? But when we say class B, we are allocating in class B, we are allocating only 16 bits. So the number of hosts or number of computers will be limited compared to the class A. So we can say it will be medium-sized networks. And the next thing that we can say, the network, we have 16 bits. We can say network, we have 16 bits. And the host, we have another 16 bits. This is the second thing that we can talk about, the class B network. Okay, the next thing that we are going to discuss, the next 2 bits. The first 2 bits I told you already, it's starting from 1 and 0. Then the remaining 14 bits we allocated for the network ID. And the remaining 16 bits we use for the host ID. Right? So we can say that, okay, the first 2 bits is always 1, 0 that we have already discussed. The first 2 bits. And then first 2 bits always 1 and 0. Then 14 bits we will use to determine the network ID. And the remaining we use to determine the host ID. Right. Now let's look at the subnet mask. Now I told you the subnet mask is to identify number of bits allocated for network and then host IDs. So when you talk about number of bits, so the network IDs we represent using 1, then the remaining, the host IDs with 0. That's the idea. Right? So we will have how many ones then? We have 16. 4, 8. So let me take, right? And then we have another 8. So this is used for network and remaining for the host. That means the computers in the network. Right? So this is what we use for as a subnet mask. So when you convert this to decimal, so the first 8, because we talked about this earlier, we allocated. So the first 8 will represent 255. The next 8 will represent 255. The remaining 8 will be 0 and 0. So usually in class B, we say that default subnet mask is 255, 255, 0, 0. Right. The next one we need to discuss is the range of IP addresses. What is the range? What is the minimum and maximum? So to talk about the range of IP addresses, right? we could say, okay, the range. And the theory goes from, it's the same. So we can say a range of IP addresses for class B. Now, when you talk about the IP addresses, remember it's always start with 1 and 0. So we talked about this earlier. Right? So the minimum should be for the network, another set of zeros, right? So that you can put. And then the maximum could be you start with 1 0 and the remaining will be all ones. So we can say that the range, right? Range of IP addresses for class B, we can say that, okay, so you start with 128, 0, 0, 0. Then you go with all ones for the network. That means 1, 0, then all ones, right? That's how we say. So that will be 191, then 255, 0, 0. So if you're wondering how we got 191, all ones, meaning, so what we had was 1, 0. The maximum is the remaining 6 should be ones. And then the remaining also will be 1. And when you add it up, when you convert it to decimal, so this will be 191. Okay, right. So now let's look at the number of hosts, the number of computers we can have in a network. Now, when we talk about number of hosts, right? Now, one thing you need to remember is we can talk about the number of hosts is always the number of hosts that you can create using 16 bits. Yes, that's how you can start. So when it comes to class B network, we know we are going to allocate 16 bits for the hosts. So when you say 16 bits, right? So the number of hosts, we can say it's 2 to the power the number of bits we allocated for the host, and we subtract 2 because the first and the last one we are going to ignore. We will allocate for special, we'll talk about it. And then here we are using 16 bits, 2 to the power 16, right? And minus 2. So when you take 2 to the power 16, when you calculate it, you will get 65,536 minus 2, which will end up with getting 65,000 computers in a network, which is Yeah, medium to large network. We consider it as a medium to large network. Right. The next thing that we are going to talk about is class C addresses, right? We are going to talk about class C. So in class C, what we know is we can create large number of networks, right? Class C, we will have large number of networks. And the other thing that we need to discuss is class C, right? We are using 24 bits for the network, and then we will use 8 bits for the host, right? So that's how we will create class C networks. So the class C networks, we can say we are using 24 bits for the network, and then remaining we will use for the host. Right. And the other one we want to discuss is it starts with 110. Okay, so let's write down. We can talk about the first. It uses 24 bits. We can say it uses 24 bits. And yeah, when you say 24 bits, actually the 21 bits if you ignore the first three. And then the next one is you are using 8 bits, the smallest number of computers you could have, right? And the other one is it start with, as I told you earlier, 110. So it start with 110, right? And then the remaining could be so this is for the network, and the remaining 8 bits we will allocate for the hosts. So that's how the class C looks like, right? That's how the class C look like. Now let's continue. Now when we talk about the class C, the few things we can talk about. Yes, we can talk about IP addresses belongs to smaller size. IP address belongs to class C are assigned to small size. Networks. Now, why we call it a small size? Because it uses only 8 bits. And then for the network ID, we can say it uses 24 bits, and the remaining, that is host ID, it uses 8 bits. So that is the next thing that we need to discuss. So that part is also clear. And the next, we could talk about the first 3 bits. So when you talk about the first 3 bits, we can say the first 3 bits are always set to 110. So that's the one thing we need to discuss. So that means the remaining, we have 21 bits are used to determine network bits. Okay. So the next one we are going to talk about is the subnet mask. So we can say the default subnet mask for this is let's talk about the default subnet mask. We can say default. So what you need to remember about this one is when you talk about the subnet mask, we set all one for the network. So we will have all ones. We have 24 bits. We have 24 bits, all ones. And the remaining 8 bits, we have 0. So in default decimal notation, we can say this is 255, 255, 255, and 0. Right. Okay, so let's look at now the number of addresses we can have. So when you talk about the number of hosts, for example, now we know. Okay, before that, let's talk about the IP ranges. So we talk about the range of IP addresses. So let's talk about that. So the range of IP addresses, we can talk about the range of IP addresses for class C. So let's talk about the range of IP addresses. Now in class C, we can say it start with 192 because it start with 110, right? So when you say 110, right? First 3 bits are already set. Right? Because it's 110. So all 0, which creates the lowest number. So it should be 192, 0, 0, 0. And it goes up to all ones. That means 110, all ones. When you say all ones, it ends up to 23, 255, 255, and 0. So this is the IP address range we can for class C. Now let's talk about number of host addresses. When you talk about number of hosts, earlier we discussed the equation that we could use, number of hosts, right? So we can say in this particular case, when you talk about number of hosts, that means 2 to the power number of bits for the host, and then we'll subtract 2, right? Now, this time we know it's only 8 bits. So 2 to the power 8, that is 256, subtract 2, which will give us, right, 254 host addresses. So these are the number of hosts we can have. Now, similarly, we can talk about number of network addresses as well. Now, for that, we can use 24 bits. Out of 24 bits, the first 3 bits are fixed. So that means 2 to the power 21. If you take that into account, you get about like 2 million, right? So we can say that, right? There are 2 to the power 21. Why 2 to the power 21? Because the first 3 bits is fixed, right? Only the remaining that we can change. That is 2,097,152. So this many network addresses are possible. So there are network addresses. Are there? Right. So, and the remaining 2 classes we are not going to talk about much. Class D, it's used for multicasting, and the range will be from 224 000 to 239 255 255 255. And class E, it goes from 240 000 to 255 255 255 2554, right? So let's write down those and we'll finish. So we can talk about class D. So in class D, the only thing that we can discuss is the IP addresses are limited. So in this particular case, we can say class D IP addresses, right? We can talk about IP addresses. In this particular case, IP addresses are allocated and reserved for multicasting. So we talk about multicasting, right? So when you want to send it to multiple, computers, and that's the first thing. And then when you talk about the IP ranges, we can say the IP address range. It start with 224.0.0.00002. It can go up to 239, 255, 255, 255. Right. So that's all what you need to remember about the class D. So similarly, let's start with the class E as well. So the next one is class E. So class E addresses, again, for experimental and research purposes, they have allocated these set of IP addresses, which again, we are not concerned about creating networks, right? So we can see IP addresses. IP address, it's reserved for special purpose. We can say IP addresses are reserved for experimental and research purposes. So we can see the range of IP addresses we can have. IP address range 240,000, and then it should go to 255, 254, right? So that's about the class E addresses. Summarize everything, right? So let's take a small table. We'll summarize what we have discussed so far. Now, summary, right? This is what we need to summarize. We will have, we can talk about the first three classes because this is more important compared to the last two. So we can talk about the address ranges. We can go from class, and then we can talk about the address range. Then we can have a start bit. Starting bits. Then we can talk about length. Then we can talk about number of networks. Then we can talk about number of hosts. Right. So we will have class address range, and then we can talk about the starting bits since the spacing is not enough. I'm going to use some spaces. So starting bits. Then we can talk about length of network ID. Then we can talk about number of networks. And then we can talk about number of hosts. Right. So let's start with class A. So we know that class A, we have class A, class B, and class C. So these are the three classes we are going to consider on this. Then when we talk about the IP ranges, it goes from 1 to 126, right? That's the first one. Then B goes from 128 to 191. Then C, 192. It goes to 223. So that's what you need to remember about the address ranges. The next one is a starting bits. So start bits for A is 0, and then B is 10, C is 110, right? So those are the starting bits for class ABC. The length of the network IDs, again, we know. For A, we have 8 bits are allocated. Then B, it's 16. C, it's 24. Yes, this is length. The number of networks we can talk about. It's 8 bits and then 2 to the power 8. That is 255. But you remember the starting bits is 0. So that goes to 128. And you remove the first and the last. Then you end up with getting 126. Similarly, we have 16 bits, but the 14 bits are allocated there. 60,386 minus 2. So we have 16,384. And 24 bits, although 24 bits, the starting 3 bits are fixed to the power 21. So we will have 2,097,152 when you ignore the first and the last. So these are the number of networks we can have. Then number of computers you can have in a network. So we discuss you have 24 bits for the hosts, and the first and the last we are going to ignore. So we'll end up getting 16 million, right? So we'll end up with getting 16 million. Yes, the cost of computers in the network. Then when you have 16 bits, 65,536 minus 2, we will have 534. And then last one, we have 8 bits. The maximum is 256 minus 2. So you will have 254. Right. So that's the summary of the classes A, B, C. So the next thing is who will be assigning the IP addresses. So usually the IP address assignment done by the internet service providers. In our case, the companies, the internet service such as the telecom, the Dialog, Mobitel. So those are the ones actually who assign this the IP addresses, right? And then when you have the computers in the network, we call the hosts. They will have the same network address or set the same address prefix are there. So that's usually how it happens. So with this part, we are concluding about the classes, and then we are going to talk about the very important one, which we call subnetting. That means how you can divide a computer, or how you can, large network into smaller networks. So this is called subnetting. Topic, which we call subnetting. So the subnetting is a topic that we will use to talk about how you can divide large network, right, to a smaller network, right? Large network is a smaller network. So this is called subnetting. Now, when you look at, let me take an example. This example I have taken from Wikipedia, just to explain or elaborate what really happens, right, in a network. So let's say we have a network. Now, when we talk about the networks, now one thing you need to remember, we have a IP address, and then we have a range of IP address. So let's say we have given this range of IP address. Let's say the IP address is allocated for the network is 200, 100, 10, and 0, right? So when we talk about the range of 200s, we know it's a class C address, isn't it? It's a class C address. So in class C address, we know that in total, we can talk about 256. Just when you remove the first and class, we get 254. But, you will get 256 addresses, right? And then we know in class C addresses, there are 24 bits allocated. So when you say 200, 100, 10, 0 / 24, this 24 indicates number of bits allocated for the network. This is another way to represent network, which we will discuss later on. So simply this will say that, okay, this is the IP address allocated for the network, and this is the number of network bits. Sorry, yes, number of network bits. Right now, so the range of IP addresses we can think of is, so you start with 200, 110, and 0, and this can go up to 255, isn't it? So that's how we are getting 256 addresses. Now we have 256 addresses. Now let's say I want to divide this into two networks. So ideally, when you say dividing this into two networks, so that what it means, right? The half of these addresses will be in one, the other half will be in the other, right? So simply you can say the first 128 will go to one network, the other 128 will go to other network. Now, if you look at the ranges now, it goes from 0 to 127, and then the next will go from 128 to 255. So this is same as you are actually borrowing one more bit from host to the network, isn't it? Now think about this. Now we know that number of bits allocated for the host will determine the number of computers. So it's like now we are going to borrow a bit from the host to the network. So we end up getting 25 bits for the network. That means remaining 7 bits will determine the number of hosts. So that's how we are going to talk about this. So let me give you, you don't have to take down this. So let me start discussing the idea of subnetting. So let's write down. We can talk about the idea of subnetting is, we can say it's a process of dividing IP addresses. And by dividing, we are going to create small networks. So you can write down that saying that, okay, subnetting is a process we can use to divide the large IP network into a small IP network. And it allows us to create two small networks. So in the Excel point of view, usually they will ask you to, it will give you IP address and they will ask you to break it into 2 networks, 4 networks, 8 networks, and so on. You should know, like, okay, how do you do that? Right? So that is exactly what we are going to talk about in this part. The first step of any given subnetting problem, that means dividing a large network to smaller network, is you need to identify what is network portion and what is the host portion. Now, usually default subnet mask is 32 bits, where network bits are set to 1 and host bits are set to 0. So when you are given subnet mask, you should know that, okay, how many bits are allocated for the network and how many bits are allocated for the hosts. So that is the first step, right? So that is the first step that you are going to understand. How do you understand, or how do you identify the number of bits allocated for the network and some number of bits you allocated for the hosts? So we were discussing about the subnetting, that is dividing a large network into smaller networks. And I told you the first point is identify what is network portion and then what is the host portion. So given IP address, so let's see how you can actually identify this. First part is identify the default subnet mask. So let's start with this example. You have given 3 IP addresses. So let's start identifying what are the default subnet masks are.